Alright guys, so today we're going to continue with coordinate geometry, and we're going to add right triangles to our list as well as rhombuses and squares. So again, the purpose of today is for you to be able to classify triangles and quadrilaterals in the coordinate plane using their properties, postulates, and theorems, with or without a grid. You also need to be able to prove that a given figure in the coordinate plane is a specific triangle or quadrilateral using sufficient criteria. Okay, so before we begin, let's refresh our memory. This is our toolbox. Okay, we're going to be pulling from here, and we're also going to be pulling from the fact that we know that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. Alright, so let's look at this figure right here. This is obviously a triangle, but more specifically, it is a right triangle. Now, when I think of right, I think of 90 degrees, and I also think of perpendicular. Okay, so I'm going to draw my 90-degree symbol right here, a box in the corner. And the one property that we are going to have to prove about this shape is that it has one right angle. One right angle. Now, in order to prove that it has one right angle, we are going to need to perform the slope formula 3 times. Okay, one time for each side. So 1, 2, 3. Alright, the next shape that we have right here is a rhombus. Okay, and the one thing that we need to do in order to prove that this is a rhombus is we need to prove that it has 4 congruent sides. Okay, so that one property is 4 congruent sides. Now, since we're trying to prove congruent sides and sides have length, we are going to perform the distance formula, and we're going to need to perform the distance formula 4 times. Okay, last but not least for today, we have a square. And a square, just like a rhombus, a square is a rhombus, and a square has 4 congruent sides. But remember, not only is a square a rhombus, but a square is also a rectangle. So a rectangle specifically has 4 right angles. Okay, so for this one, we're going to need to prove that it has 4 congruent sides, which means we're going to do the distance formula 4 times. Okay, and then we're also going to have to prove these right angles, and the way we prove right angles is with slope, and so we're going to need to prove that it has 1 right angle. Okay, so since we have to prove that this side is perpendicular to this one, or we can prove this side is perpendicular to this one, or this side is perpendicular to that one. Since we only have to prove that one pair of sides is perpendicular to each other, then we're going to have to perform the slope formula 2 times. It doesn't matter which pair of sides you choose, just choose a pair of sides that intersect one another. Okay, now remember, when developing a coordinate proof, just like we did yesterday, the first thing we want to do is draw and label the sketch. Sketch a graph when one is not provided. Second, we're going to state the formulas we're going to be using, whether it's slope or distance for today. Third, we're going to show all of our work. And last but not least, we're going to write a concluding statement stating what we have proven and why it is true. Okay, those are the 4 formulas, those are the 4 parts of our recipe for a proof. Okay, so let's go ahead and get started with our first proof. Alright, number 1, prove that ABC is a right triangle. Let's go ahead and graph these. A is at 0, 1. B is at 3, 4. and C is at 5, 2. Okay? After you graph those points, you plot those points, grab your ruler and connect them. And again, we're trying to prove that this is a right triangle. Now, if you graph something correctly, you can kind of see where the right angle might appear, and it looks like the right angle might be right here, but we really can't be sure until we see the slope of this side and this side. If these two sides have opposite reciprocal slopes, then this is definitely a right angle. Okay? So, what do we need to show? We need to show that it has one right angle. Remember, right is 9 degrees, and it's also perpendicular. Okay, what formulas do we need? We need the slope formula. So just quickly review the slope formula. Slope is lowercase m is equal to y2 minus y1 over x2 minus x1. Okay, so let's go ahead and start showing our work. Our work is to calculate all three sides, the slope of all three sides, to show that only two sides are perpendicular, opposite reciprocal slopes. All right, so let's go ahead and name our sides. Let's do side AB, side BC, and let's do side AC. Alright, AB. Go ahead and label them. So, let's do Y2. Okay? So on top it needs to be Y2, which is 4. Take away Y1, which is 1, over X2. Okay? So 4 minus 1 is 3. 3 minus 3, that is 1. So the slope of side AB is 1. So M is equal to 1. Let's find the slope of side BC. So BC, notice we already labeled it as X2 and Y2. So let's go ahead and label C as X1 and Y1. Okay. Our numerator, Y2, 4 minus Y1, 2, over X2, 3 minus X1, 5. Okay, 4 minus 2 is 2, 3 minus 5 is 2, and this is equal to 1. So right now we have two lines that have the same slope. Wait, 3 minus 5 is negative 2. Oh, so there we go, negative 1. I knew there was something wrong. So 3 minus 5 is negative 2. 2 divided by negative 2 is negative 1. So notice, opposite reciprocal slopes. And we know it's opposite reciprocal slopes because first, in order for it to be opposite reciprocals, the signs have to be different. This is positive, this is negative, and the numbers have to be flipped. Okay? So let's see what the slope of AC is. So AC, since both of them are labeled as X1s, let's just go ahead and change this one to X2. Again, it doesn't matter which one you change, you just got to change one of them. So Y2, 2 minus Y1, 1, over X2, 5 minus X1, 0. So 2 minus 1 is 1, 5 minus 0 is 5. And notice, there is no relationship between this slope and the rest of the slopes. Okay? And that's this one right here has a slope of 1/5. So again, we showed that AB has a slope of 1, BC has a slope of -1, so that means they're opposite reciprocals, and that's where our right angle appears. Alright? So side AB is perpendicular, that's the perpendicular sign, to side BC. Okay? So, we have just proven that triangle ABC is a right triangle because it contains one right angle. Alright, next one, number 2. Prove that a quadrilateral with vertices A, B, C, D is a rhombus. So again, go back to our rhombus. What makes a rhombus a rhombus? A rhombus just has 4 sides that are congruent. So we're going to need to perform the distance formula 4 times. Alright, so first thing, sketch a graph. Notice a graph was not provided for you, so go ahead, grab your ruler again. We're just going to create an X and Y axis. Remember, there's nothing perfect about it. All we're doing is making sure that our lines are straight, but we do not have to measure. So don't focus on perfection right here. I'm going to draw my arrows. Okay, and that's a sketch. Now, we need to sketch these points. So A is at -1, 3. So that's about somewhere up here. That's A. B is at 3, 6. So if this was 3, then 6 should be somewhere up here. And C is 8, 6. So about somewhere over here. And D is 4, 3. So about somewhere right here. Okay? After I kind of do my sketch of where I think, an estimate of where I think those points should be, I'm going to grab my ruler again and connect them. You can kind of see it kind of looks like a rhombus, but again, we have to prove that it's a rhombus. If the numbers do not check out, then it is not a rhombus. Okay? So what do we need to show? We need to show that it has 4 congruent sides. And in order for us to prove that it has 4 congruent sides, we're going to need to perform the distance formula 4 times, once for each side. Okay? I'm going to go ahead and grab my calculator because we're about to start calculating. So if you haven't grabbed your calculator yet, go ahead and take this moment to take it out, turn it on, and let's get ready to calculate. Alright, so our work, we're going to calculate the distances of all 4 sides to show that they are all congruent. Okay, so let's do side AB, BC, CD, and AD. Again, all I do is go over here and list them, all 4 sides. Doesn't matter which order you list the letters again. I could have said BA, CB, DC, and DA, and then we would have still gotten the exact same answers. Okay, so notice I kind of have set up the distance formula for you. Again, this has to be memorized for the common assessment and your unit exams. Okay, so let's do AB first. So x1, y1, x2, y2. Okay, so the first set of parentheses has your x's, the second set of parentheses has your y's. So we're going to do x2, 3 minus x1, -1. y2, 6 minus y1, 3. Okay, I'm going to grab my calculator and begin plugging this in. So square root house, our radical house, parentheses, 3 take away -1, go to the right once, square, plus another set of parentheses, 6 take away 3, go to the right once, square that, go to the right once, I'm going to hit enter, and I get 5 for the length of side AB. So again, we're going to pause. In order for us to say this is a rhombus, we must get 5 for the next 3 times. If we do not get 5 for the next 3 times, then this is not a rhombus, and that's what we're going to state, that quadrilateral ABCD is not a rhombus because it does not have 5 sides. But again, we only have to do that if we don't get 5 here. Let's hope that we get 5. Alright, so let's go ahead and do BC now. So B is already labeled as my x2s and my y2s, so I'm going to label C as x1 and y1. Okay, so x's first, x2 minus x1, y2 minus y1. Okay, so I'm going to grab my calculator, radicals house, parentheses, 3 take away 8, go to the right once, square, plus, parentheses, 6 minus 6, go to the right once, square that, go to the right once, hit enter, and I got 5 again. So right now, we have 2 that have 5. Okay, CD. C is already labeled as my x1 and my y1. Let's label D as x2 and y2. Okay, X is in the first parentheses, y is in the second. So x2, alright, let's try that again. Sorry about that, the lights went out. Of course, I'm sure you guessed that. CD, alright, so x2, 4 minus x1, 8. y2, 3 minus y1, 6. Okay, I'm going to grab my calculator, square root house, parentheses, 4, take away 8. Go to the right once, square it, plus parentheses, 3, take away 6. Go to the right once and square that. Go to the right once, hit enter, and I got 5 again. So right now, again, so far so good. We need to get 5 for this last one to say that this is a rhombus. Okay? So last one, AD. Notice that A we've already labeled as X1s and Y1s, and D's already labeled as X2s and Y2s, so we are good to go. So X2, 4 minus X1, -1. Y2, 3 minus Y1, 3. Okay? So radical house, parentheses, 4, take away -1, square, plus, parentheses, 3, take away 3. Go to the right once, square that, go to the right once, hit enter, and we are good to go. Alright? So, because AB is congruent to BC, which is congruent to CD, which is also congruent to AD, we can say that quadrilateral ABCD is a rhombus because it has 4 congruent sides. Alright, last one for today. Prove that the quadrilateral with vertices A, B, C, D is a square. Okay, so going back to what exactly a square is. A square is a combination of a rectangle and a rhombus. So a square, we not only have to prove that it has 4 congruent sides, just like we did right now for a rhombus, but we're also going to have to do the slope formula twice to prove that it contains 1 right angle. Okay, so go ahead and get started. We're going to plot the first point. A is at -1, 0. B is at 3, 3. C is at 6, -1. And D is at 2, -4. Okay? So I'm going to grab my ruler. I'm going to connect all 4 points. You can kind of tell it kind of looks like a square, but again, we can't say for sure unless we get the numbers. So the numbers will prove that this is a square. Okay, so what do we need to show? We need to show that it has 4 congruent sides, and then we need to show that it has 1 right angle. Okay, what formulas do we need? We need both the distance formula to prove the length of the sides and the slope formula to prove that it has 1 right angle. Okay, so let's go ahead and calculate the first 4 sides, and then we're going to calculate the 2 slopes. Okay, so let's do side AB, BC, DC, and AD. Alright, AB, X1, Y1, X2, Y2. Okay, X is first. X2, 3 minus -1. Y2, 3 minus 0. Okay, so I'm going to grab my calculator. Square root house, set of parentheses, 3, take away -1, go to the right once, square that, plus another set of parentheses, 3, take away 0. Go to the right once, square that, go to the right once, hit enter, and I got 5. Okay, side BC, let's go ahead and label this as X1 and Y1. Ooh. Alright, so X2, 3 minus X1, 6. Y2, 3 minus Y1, -1. Okay, square root house, parentheses, 3 minus 6. Go to the right once, square that house, plus another set of parentheses, 3, take away -1. Go to the right once, square that house, plus another set of parentheses, 3, take away -1. Go to the right once, square that house, plus go to the right once, hit enter, and I got 5 again. Okay, so pause and let's make sure that we understand what's about to happen. In order for us to prove that this is first a rhombus, we need to have 5, 5, 5, 5 to prove that it has 4 congruent sides. Then in order for us to prove that this is a rectangle, we need to show that it has 1 right angle. So right now we're on the path of proving that it's a rhombus and a rectangle, which would make it a square. Okay, so let's move on with DC. C is already labeled as my x1 and y1, so we're going to label C as x2 and y2. So x2, 2 minus x1, 6. y2, negative 4 minus y1, negative 1. Okay, so I'm going to grab my calculator, square root house, 2, I'm sorry, didn't even do my parentheses, 2, take away 6, go to the right once, square it, plus, parentheses, negative 4, take away negative 1, square that house, and then I'm going to hit enter, and I got 5 again. Last one, AD. Notice that A is already labeled as x1s and D is already labeled as my x2s, so we can go ahead and move forward with that. x2, 2 minus x1, negative 1. y2, negative 4 minus y1, 0. Grab my calculator, square root house, parentheses, 2, take away negative 1, square, plus, parentheses, negative 4 minus 0, square, enter, and I got 5 again. Okay, so side AB is congruent to BC, which is also congruent to DC, DC, which is also congruent to AD. So we've just proven that this square is a rhombus. Now we need to prove that it is a rectangle. So we're going to perform the slope formula twice. Okay. Remember that the slope formula shows that we're using the slope formula to show that there is 1 right angle, and right angles would mean that the sides are perpendicular to one another. So let's go ahead and choose 2 sides that we want to say are perpendicular to one another. We can choose these 2, these 2, these 2, or these 2. Doesn't matter which ones, just make sure that they are 2 that intersect. So I'm going to do side BC, and I'm going to do side DC. Again, doesn't matter which one you choose, just choose a pair of 2 that intersect. Okay, so let's do the slope of BC first. So we're going to go back up here, BC. Notice that one of them is already labeled as x2 and y2 and x1 and y1, so we're just going to go ahead and use them as is. So the numerators are your y's. So y2, 3 minus y1, negative 1. x2, 3 minus x1, 6. Okay, so I'm going to grab my calculator. I'm going to do 3 minus negative 1, and I get 4 as my numerator. 3 minus 6, and I get negative 3 as my denominator. So right now the slope is negative 4/3. Alright? Now in order for these 2 sides to be perpendicular, I'm going to have to get positive 3/4 right here, because that would be opposite. Opposite would be positive. Reciprocal, when we flip this, it would be 3/4. So I need to get positive 3/4. So let's see if we get that. DC, notice again, we already have x1s and x2s labeled, so we're going to go ahead and move forward as is. Your numerator is your y's. So y2, 4, take away y1, negative 1, over x2, 2, take away x1, 6. Okay? So negative 4 minus negative 1, I get, let's see if I did that right, y2, negative 4, y1, negative 1, so I get negative 3. My denominator, I get 2 minus 6, and that gives me negative 4. A negative divided by a negative would give me positive 3/4. Okay? So, we needed what we exactly wanted. The opposite reciprocal would be positive, and the flipped version of this is 3/4. So BC is perpendicular to DC. Okay? So let's go ahead and write our concluding statement. Quadrilateral ABCD is a square because it has 4 congruent sides and it has 1 right angle. Okay, now go ahead and begin your homework. You have one of each to do on your own. At the end of the last one, you'll see there's a little reflection, so go ahead and take a moment to fill out this reflection. If you would like, please go ahead and read it, but if you do not have any questions, you are good to go.